Presenter number 14, from Grouping 1, Sciences and Health, is Dr. Daniel Bucher from Southern Cross University with a presentation titled A New Perspective on Pufferfish. When you're ready.
All right, well, I'm going to present one example from a broader research program of mine that looks at the age and growth rates of various marine creatures. Now, normally I do that sort of work in order to develop a sustainable harvest strategy for each species. But in this case, pufferfish are deadly poisonous to eat, so we don't want to harvest them. What I want to do is promote their use as a biomonitor of estuarine pollution. Now, there's great need in pollution studies for consistent methods that can be applied to the similar creatures across a broad geographic range. And pufferfish show promise of being able to do that. This is the banded and common puffers from northern New South Wales, where I come from, but every estuary from Darwin to Hobart and at similar latitudes around the world supports at least one similar species to these. Now, in order to be a good biomonitor, an animal needs to meet a number of criteria. Firstly, they have to be tough enough to live in polluted environments. But the two criteria I'm going to talk about are that they should live a relatively long time and not move around very much. That way they accumulate pollutants in their tissues that can be related back to a specific location. So, how old are my pufferfish? Well, I first asked that question of my second year fisheries students, and the answer I got back was that of all the fish they were asked to age, puffers were by far the hardest. That's because to age a fish, you normally extract their ear bones, take a cross-section and count growth rings like you would in the trunk of a tree. The trouble is pufferfish ear bones are the size of a pinhead and they're a very odd shape, as you can see in the top picture. So we decided the best idea was to give that problem to a PhD student. And Rumiida Matpia took on the challenge, and she concluded that the oldest fish in her sample turned out to be 27 years old. 27 growth rings on a cross-section of a pinhead. As a supervisor, I was pretty impressed. We also looked at another structure that has annual growth marks in it that's unique to pufferfish, and that's their beak-like teeth. Now, unfortunately, teeth erode and you lose the older layers, so you can't tell the age of the fish from the teeth, but you are left with the most recent growth, up to about 10 years worth. And if you do some microchemical analyses on that, you can actually get information on past environmental conditions that the fish was exposed to, including past pollution events or remediation works. So that's an advantage that puffers might have over other potential candidates as biomonitors. So do they move around very much? Well, we started by doing some acoustic tracking work that showed the same little fish swimming up and down the same mangrove creek every high tide for months on end. So we figured the chance of catching that fish on multiple occasions was pretty good. And we started a long-term tag and recapture program in which we inject small microchip pit tags, the same sort of tags that vets use on dogs and cats to identify individuals. And we have the dual aim here of looking at longer-term site fidelity and also independently confirming the rather surprisingly old age and slow growth rates from the earbone study. Now, this sort of program takes longer than your average PhD, so in a great exemplar, I think, of the teaching research nexus at universities, this has moved back to the classroom, and every year for the last 5 years, my fisheries students and I have resampled Rumi's sites, caught some of her fish, and just this year we've accumulated enough recaptures to start looking at a publication on the joint data set. What I really like about this sort of study, though, is it's one of the rare opportunities for a fish biologist like me to actually see his samples more than twice, and on the second time they're still alive. Terrestrial biologists do this all the time, but when I go to a fisheries conference, I feel a little like the hobby farmer who's asked the shearer to shear my 5 head of sheep. What are their bloody names, he says. Well, Fat Freddy there has been caught 5 times in 4 years. He's grown 2.5 centimetres in that time, and he once got caught in a net that was dislodged by the tide currents and hung in a mangrove tree for 2 hours out of the water. He survived to be caught again the next year. Remember, I said they had to be tough. So we've shown that puffers live for more than 20 years. They spend most of that time hanging around the same very small area, and their teeth may give us an archive of past environmental conditions as well. We're now working on relating the pollution levels in their tissues to what we find in the environment. But personally, what I've got out of this is a new respect for these unique little fish. I've seen kids catching them off jetties, rolling them on the ground until they puff up like a tennis ball and then stomping on them so that they explode like so much living bubble wrap. I've spent more than 5 minutes talking to them about it as well. Fishermen call them bait thieves. We also call them toadfishes, and we seem to treat them like they were some kind of marine cane toad. They're actually a very long-lived native fish that could end up proving very useful to us. And I hope that from this, like me, you've got a new perspective on pufferfish, Ned.